So what does that mean and where are we heading? That heads with these two vocabulary. At any point in time you want to stop. Of course, this PowerPoint is uploaded for you. You want to stop the video and record, write these down. But these are two biggies, and you're going to see these on a short answer on your test. Is the difference between an intramolecular force and an intermolecular force. So TRA and TER. So TRA, intramolecular force, is the bond that holds the molecule itself together. So a water molecule, the covalent bonds inside of the water molecule is an intermolecular force. That is what we've been doing in Chem 1. We were doing covalent bonds and ionic bonds. We were doing intramolecular force, TRA. An intermolecular force is a bond. It's really not a bond. And we say force. Sometimes it's referred to as a bond, one of them, hydrogen bonding. It's not really a bond, it's more of an attraction. Intramolecular force is kind of like a marriage. Intermolecular force is more of an attraction. And so let's look here. I like this little drawing that they've got here. So I've got some two hydrochloric acids here. So the bond here, this is a polar covalent bond. Polar because this guy's more electronegative than that guy. This is a polar covalent bond. This is an intramolecular force. This one right here is intra. Okay. This one here is intra. It is holding the molecule together. What this one is here is a slight attraction that this molecule has for this molecule over here. And this is a weaker force called an intermolecular force. What that matters is this. When we break this one here, we get chemical reactions. Chemical reactions are going on here. I break this one, we get a chemical reaction. If I break this weaker attraction, we're just going to change states of matter. That's a physical change. We go from a solid to a liquid to a gas. So intermolecular forces are what holds solids together. We break a few of those, we get liquids because the molecules can move more. We break some more, we get gases. So intermolecular forces are basically what's holding a bunch of the molecules, billions of water molecules together. Okay, that is the difference. And we're going to look at the different types of intermolecular forces. So this first slide I'm going to go kind of fast through, and then we'll come back through each type. This one's just saying. So when you boil water, you are breaking intermolecular forces. That's just to vaporize it. It's still water. But to break the hydrogen and oxygen bonds, that's a lot more energy. Look at the difference in the kilojoules here. So when you boil water, you are not separating the oxygen and the hydrogen. So it says generally intermolecular forces are much, much weaker. So a lot less kilojoules of energy involved. So the first one we're going to look at, and some books don't tend to pay attention to this one, but we're going to go ahead and throw it in there because some of our questions have it. So our strongest bond, and this one fits into both categories of inter and intra. Ionic compounds, there's really no difference. The intermolecular force and the intramolecular force are the same thing because there's a bunch of ions just being held together. So that's going to be our strongest one. We're going to know that one because it's going to be a metal, non-metal. When we do the little worksheet, and we will do that together in class, these will start to make more sense for you. Our next one is called hydrogen bonding. This is our next strongest. So ion-ion interaction, which are ionic bonds. Next one is called a hydrogen bond, and I know a lot of you probably, if you're a biology major, have heard of hydrogen bonding. This is a special type of intermolecular force where hydrogen has to be attached to N, O, or F. So you have to remember hydrogen has to be in hydrogen bonding, and it has to be with nitrogen, oxygen, and fluorine. Those three are so electronegative, we get this special type of attraction that goes on with molecules that have those elements. The next one's going to be called a dipole-dipole interaction. We're going to see that between all polar covalent bonds. And our last but not least is going to be London dispersion forces. Everything has London. So everything's going to have London dispersion forces, also sometimes just called dispersion forces. Even just pure elements, like just a noble gas, has a London dispersion. And so ionic compounds have London dispersions. Even if they have hydrogen bonding, they've got London dispersion. Even if they're dipole-dipole, they've got London dispersion. So everything's got London. All right, you can copy that. We're going to walk through each